I'm Subhadeep Ghosh from ProMiles, and I'm a technical manager for the Ashtoware BRDR development team. And today I'm going to talk about the analysis results comparison tool, and the name is we call it the ARC tool. And this tool has been uh, we have been talking about this tool from I would say for a long time, but specifically from the 2019 Radbug meeting in Lake Tahoe, and uh, and it has gone through a lot of planning, and it has eventually uh, been created, and it's ready to go. So we're all excited about this. So beginning with this presentation, so let's talk about a brief history about how we uh, did regression testing before this. Uh, a very common way of doing regression testing was to run batch analysis on your uh, on your 100 bridges, say for example, and like you can see on the right hand side, you select single rating level per row, and then you copy this grid and paste it on an Excel spreadsheet, and then you can add your formulas to compare version. I'll say legacy. I'll go to legacy. I'll say 684 versus say 7.0, and it used to be a very good process. Excel spreadsheet, or Microsoft Excel, or any open source spreadsheet gives you a lot of power to add your formulas and do whatever you want. There was also another utility that we came up with. It is called the regression test utility, and that utility through BRDR created two files, the RTU file and the SCA file, and that gave us the power to compare the actions for different bridges, and the detailed spec check output text for different bridges. But but then uh, but then through the user community, we kind of felt like there was a need for a much more simplified tool. um, so let's go to the next slide. We'll talk about the drawbacks of using spreadsheets. The advantage, like I said, you can add your custom formula. You can compare critical rating factor using custom formulas. Excel spreadsheet gives you can add tabs to your Excel spreadsheet, and you can organize your data. But but the basic disadvantage was you will have to do a multiple copy pasting step. Like you have to copy from 684, copy from 70, put it in a separate tab in Excel spreadsheet, separate tab, or you can put it in the same tab or a separate tab, and then you create another worksheet where you will have to compare the two rating factors from different versions. So so with that problem, there was the problem of you having to add your own comparison formulas. When you're writing your own comparison formulas, you can only maybe do certain things, certain tolerances on your comparison formulas. There were problems where bridges from say version A and version B, when you see it in the bridge rating results, may not line up. Maybe 5 bridges did failed in say 7.0, which ran in 684, and those bridges rating factor will not appear in the bridge rating results window. And then when you copy it from the bridge rating results window, paste it on an Excel spreadsheet, and do a comparison, uh, then your data will not be aligned for you to write a formula. And just like if it's a 100th row in your Excel spreadsheet, then it's very hard to go in there and see, oh, it's a different bridge. So you have to realign the data. And the other big problem for comparing with Excel spreadsheet was, or I would say spreadsheet was, it was a high level comparison only. It will just give you a rating factor comparison. There was no design ratio comparison as such, and for rating factor comparison, you just get the critical rating factor for the bridge itself, by vehicle and by the rating level you rate it for. Uh, Talking about the regression test utility, this was a great tool when it came out. I mean, I was blown away with this tool, of the amount of work that we can do with this. It gave us a detailed comparison of if results, detailed comparison of specification, article text. But one thing I did found, I'm a developer, by profession, I would say, but I had a hard time understanding. Not hard time. It took me some time to understand all the terminologies that we use in the regression test utility. So I would consider that for a general, for like an engineer who's trying to load rate a bridge, or trying to figure out whether a rating factor changed from version A to version B. I would think it's a steep learning curve, and so there was a time that would take for somebody to be an expert in this tool, or it would be hard for a new guy to come up with working with this tool. Also, one complaint we did here was that there are excess information for end users to analyze when you're trying to jump from one version to the other. And in one of the previous presentations, there was some question about how long it takes for states to upgrade their version of BRDR. And I think this and Mike Johnson did a presentation yesterday about testing an older version versus a new version of the software, and it's a very intensive process. So what you look at is very important. So having talked about what difficulties we faced before, I'm going to go back to the discussion we started back like maybe 2 years back. And the idea was to build a very simple tool with minimum manual intervention. It should be easy to learn and maintain, and then the users will not be exposed to a very high level of detail comparison unless they want to do a detailed comparison. uh, having some comparison statistics was also a good idea to in order to give the user a good overall feeling of what they are seeing between two versions, and also giving the also providing reports from the basic tools point of view, but also having the ability for third party developers or states can have their own developers or engineers can write some reports against a database, or not against the database, against the API, to generate their own reports outside what ArcTool would provide. So these were the basic motivations, I would say, that that we thought of when we started discussing about the Arc tool. So this is the inception where we kind of thought of an architectural diagram for the Arc tool, and think of this as one PC where you have from version 7.0 onwards, you have 7.1, 7.2, 7.3, and 7.x, maybe 8.0 installed on the same machine, and then the Arc tool can communicate with all these different versions and run analysis on these different versions for the same set of bridges and do comparisons. The on the left hand top corner we have the file explorer. So right now our intention was not to get tied down with a certain database. Like if you have a file in database, say 7.0, we cannot put that. We need to import that into 7.1, 7.2, 7.3. So we went with the file explorer concept where we have all the XML files there, and you import it into whichever version you want to run the analysis on. And also from the diagram, you can see that it has a small, the Arc tool has a small database, and it also has an API through which you can generate predefined reports, or states can generate their own reports. So, so after we came up with this architectural diagram, we decided on what we need in the Arc tool, and then this is the result of all the discussion we had for version 7.1. So this is the dataset explorer. So the concept is very similar to like Bridge Explorer, but it's not like a file explorer, but like we say for Bridge Explorer, we say it's a file explorer. We have folders and where you have different bridges, but this is a kind of a dataset explorer where you can go through a list of data sets that you have used in your ArcTool comparisons. A dataset is essentially a run on a version of BRDR that has say 100 bridges, and it ran with the certain analysis settings you have in your database for that version, and that's all. I mean that, and it has, and from the analysis settings you have the vehicles, and from the vehicles you have a certain rating factor. So one thing to note is some of the things are unique identifiers for a dataset explorer, which is the dataset name, a BRDR full version number, which is you can say 7.0.0.3001 or 7.1.0.2003. The bridge ID is unique for a data set, and then there is analysis settings, which is unique for a data set generation. Um, so going to the next slide. So this is the create dataset window. Like I said, when you generate a new data set, your data set name needs to be unique. Otherwise, it will be very hard to differentiate between two data set in terms of which data set is what. Uh, and then the analysis settings that you see here on the window is from the BRDR version that you select. And let me go back to the previous slide. I think there is also another button here that says scan BRDR, and it says gather install BRDR information. This is, I think during the demo, I think we'll talk more about how it gathers this information. But once you click on the data, it looks at what BRDR version is installed, and it will pull the data so that we can use it in the tool. So coming back here, we have, based on the BRDR version you select, we have the analysis settings that you have in that BRDR version. You can also define multiple multiple folders here using semicolon, to pick up or to import XML files that you would like to use in your ARC2 dataset comparison. I should mention that if you're doing a comparison between 7.0 and 7.2, or 7.0 and 7.1, you should always be using an XML file which is with the lower or with the older version number. So this is the create dataset window. Um, we also have the concept of append to dataset window, where like I talked about a dataset run in the first window. That's the landing window. And in this window, what you can do is, if you have a data set and you say, okay, I have 100 bridges from for version 7.0 from, say, folder X, I want to add another 100 bridges for steel, say, to the same data set for the same BRDR version. So in this case, if you look at the window here, the append to dataset window, the name and the BRDR version is actually grayed out. And for those next 100 bridges, you can either add them with the same analysis settings or with a different analysis settings. The only limitation is the bridge ID cannot be repeated, because that will create confusion during the comparison process. The next window we talk about is create dataset from. This is a very powerful feature, where if you're in version 7.0 and you already have a dataset from version 7.0, and you get a new version 7.1, and you don't want to go through and enter all the data that you had to enter when you created the first data set for the previous version. So this gives you literally 3 clicks for generating results for the newer version. As you can see on the window on the right hand side, you just have to enter the new name, and you can enter a description, and then you can pick which BRDR version you want to compare against. Now, let me tell you, there's one thing that is very understandable from here, is that uh, you can use this tool to compare between version A and version B, but you can also use this tool to compare between if you have XML files which have bridge ID A, and if you have XML files which have bridge ID B. I'm just giving an example, and A uses a certain spec version, B uses a certain spec version. You can also run those two in the same version and do a comparison. So now, as I said before, this is like a template, or we use this to go from an older version to a newer version. Uh, Other than the name and the description, you cannot enter any other data for the create from window. There's also a manage dataset window, where you can manage what bridge IDs you want in your dataset, and also it also gives you an analysis settings information in the manage dataset window. This is the dataset comparison setting. So I'll go back a little bit. Um, so if you see here on the bottom right hand corner, there is the dataset explorer controls. So we have this create, append to, create from, set benchmark, manage, compare. So if you click on that compare, if you select two items in the dataset explorer, or if you decide to set one as your benchmark, and then you can select any other row as your comparison against benchmark, and you click on the compare button, then this window will pop up. And this window is essentially tells you what you're comparing to, or what you're comparing against, and what you're comparing with. So, and then this gives you basic information about what you have in the data set. And then in this window, you can also set some tolerances that you would like to use in the comparison settings. Now we have three levels of comparisons. So all the tolerances for all the three levels needs to be entered here. And so let's go over to the next slide, which will show us talk about the levels. So the comparison levels apply to both rating factor or design ratio. So level one, we compare at the bridge level, which is pretty much the rating factor that you would compare if you're using a spreadsheet. And you would compare the critical most rating factor for the bridge between version A and version B. Level two will be structural member level, where for a bridge, for a structure, you look at all the members and you look at the critical most rating factor for the member. And level three will do a very detailed comparison at the point of interest level for every POI of a member. So this is a screenshot of the level one comparison. As you can see that this comparison is by bridge IDs. There is no structure, definition, name, or member name, and this shows the comparison, what we are comparing. The first thing that we compare is the critical most rating factor for the bridge. We also have the ability to say whether the critical most location for that bridge is the same as the previous one, and if the limit state, like the bridge A, the critical most point was for say member B for flexure, bridge B or bridge A for the second version is by shear, then this will be flagging that point as a difference between the two versions. There's also a certain there are also two more columns here that gives us a relative information about what is the runtime between the two versions of the software for the same bridge model. There's also a comparison summary. As I was saying, when we were talking about this initially, we were talking about comparison statistics. The comparison summary right off the bat gives you a certain level of comfort whether the bridge models you ran are good or not. And then there is these display controls at the bottom where you can actually shrink the amount of data you see by clicking show all within tolerance, show all outside tolerance. Also you can also see the comparison failures. Now these tolerances that we talk about here is based on the tolerances we set in the comparison settings window, which you can actually access as a read-only window from the top right-hand corner of this window. You can also export the data that you see here to a CSV file to be post-processed, based on how you want to do it. So this is the level one comparison. Let's go to the level two comparison. The level two comparison is by member, by superstructure definition, and rather by bridge, by superstructure definition, and by member. Now, as you can see here, we will list out whatever vehicles you ran, its rating or design, and then you have two sets of rating factor or design ratio, and then again very similar to what we saw in level one, except you see now for each member. And then again, very similar kind of controls we have, and again we provide a comparison summary here that we saw in the level one comparison as well. This is the level three comparison, which is a very detailed comparison for each POI of the member. And as you can see from here, that there is a span information, which is span say 1, and it's a percentage on the span, so it's 0%, 3.3%. And then also, so this window had the potential of becoming really wide, like the bridge rating summary or the bridge rating results window with multiple results or multiple rating in one row. So we we restricted this display to only show the unfactored dead load change, unfactored live load change, unfactored capacity. I would say I shouldn't say unfactored dead load change. I should say it's unfactored dead load change by percentage. As you can see from the last column, that is actually displaying the whole heading. So this gives you again like tells you whether you have any difference between two POIs in two different versions in unfactored dead load, unfactored live load, and unfactored capacity, and then also the rating factor or design ratio. Again, this window also have similar controls that I showed you for level 1 and level 2. Also, if you look here, which is this column also tells you whether the difference or whether the comparison is due to a flexure uh, limit state or whether it's due to a shear uh, action. Okay, so that's the basic introduction of the ARC tool. The advantages. I think I've already mentioned a little bit. You can compare. You can do a detailed comparison only if you need to. Like there is also a checkbox that I think we'll talk about more. You you can choose not to generate your level 3 data, but you can only go to level 3 or level 2 if you are not comfortable with your level 1 data. So it's an engineer's choice as to whether they want to do a deep dive or if they do not want to do a deep dive. Also, this also provides a path for upgrading to a newer version a lot faster than what we have done, or rather, I shouldn't say we, like what states have done historically. And it's a quick way of getting a comfort level of the new version of BRDR. As I mentioned, you can also review the impact of a specification update, or say we release a new version with MBE update 2020 interim, and you're not comfortable with it, so you may want to run with the previous version to see, or rather a previous version, or you can run it in the same version with a different spec to see whether it degrades your rating factor or it improves your rating factor. And the next point is the regression analysis from version 7.0 onwards. So essentially, you can keep a history of your regression testing from 7.0 to 7.1 to like 10.0. So essentially, you can have unlimited history if you want. I guess for the timing, that in terms of the database we use, that may be a limitation, but it is definitely possible. We also provide an API for generating custom reports, and also this is a great way for us as a development team to have a batch of bridges that we can run regression test on pretty much every other day or every week or every day, and then if any rating factors change at the detail level, it kind of is a flag for us to go and check what happened with the code the day before, so we can investigate that and see whether that is a legitimate change.